these things. Like there's a couple of different ways to do it. So I just want to give you some different options or whatever to look at. That's obviously it's bothering me. All right, so 3-1. We're going to start talking about two variable equations and functions. Chapter 2, we did one variable equations and inequalities. We did some absolute value stuff. Chapter 3, which is also in that first unit test, covers two variable equations. Now, it's typically x and y equations. Technically, they could use other variables, but by and large, they use x and y because that directly relates to this thing called the Cartesian coordinate plane, okay? The coordinate system that you're probably very familiar with as far as graphing goes has two axes. You've got the x axis, which is your horizontal. You've got the y axis, which is your vertical. And then it numbers from there. So you start, so 0, 0 is that point in the middle. Positive values of x go over here to the right. So it'd be like 1, 2, 3, 4. Okay, the negatives go over here to the left, just like a number line. Okay, the smaller it gets, the further left, the bigger it gets, further right. Y is kind of the same thing. The positives go up, negatives go down. And those axes extend forever in both directions. Now, another name for this variable equation is a relation. And just because these two variables relate to each other, and that's pretty easy to see, we'll talk about some solutions to this, because once you have two variables which are related, you get an infinite number of possible solutions. So if we were just to list some for this equation, okay, if x plus y equals 5, well, if I had like 2 plus 3, so if x was 2 and y was 3, those would be valid solutions. And as I change my x, that's going to change my y, because again, they're related to each other. So if I made my x 3, well, that'd be 3 plus 2, or if I made my x 4, I could do 4 plus 1. And then once you see a pattern emerge, these are getting bigger by 1. These are getting smaller by 1. Okay, and you can see that that would extend forever and ever and ever and ever and ever, actually in both directions. This is probably one of the first ways you ever learn to graph. This is called an XY chart. And basically what you've done is you've just made a collection of what we call coordinates. So these coordinates are ordered pairs. They always go x first and then y, and those give location on the graph. For example, the point 2, 3, if we were going to graph it, means to go positive 2 on the x and then to go positive 3 on the y. It would be that point right there. So this 3, 2 means to go 3 units in the x, 2 units in the y, be there. 4, 1, 5, 0, 6, -1. And if you do this with really good graph paper and you're really neat and meticulous, then everything should fall in a perfectly straight line. And this line represents all of those possible solutions. So when we put the arrows on the end, it shows that that goes on forever. So that would include any and all possible solutions to this particular relation or equation. Now, also, it would include all the little decimals in between. For example, 2.5 and 2.5 would add to get 5, and that would be here, or 2 1/4 and 2 3/4. Okay, so all of these little decimal approximations in between also count. They're just not as easy to see as the pretty little whole numbers, but all of that works. So when it comes to a relation, it can always be graphed on a coordinate plane, and it will typically make a straight line. Almost everything we deal with in this chapter is a straight line. However, they're not all that way. So real quick, I want to discuss the difference between a linear function and then a non-linear function relation. Okay, linear obviously makes a straight line. So if you were to graph it, okay, it could look like that. Could look like that. Could be perfectly horizontal. Anyway, it's just a straight line. Any straight line is a linear function. As an equation, what that will look like is you'll just have y and x, or just y or just x, but there's no exponents, there's no square roots, there's nothing funky. You can have fractions, but your x is just an x and your y is just a y. These all relate to or represent linear functions. On the contrast, non-linear functions then do not make a straight line. Non-linear functions could be a parabola. It's like a U-shaped curve. Could have like an S-shaped curve. You could do really any shape. Could be a W-looking thing. Okay, lots of different functions. You can have ones that start here and then do kind of that thing. You get a non-linear graph from an equation where one of your variables is squared or cubed or taken to the fourth power. So if you start seeing exponents on either variable, that will give you a non-linear function. Or square root. Or absolute values. Anything you do like this to a function, square root, absolute value, x squared, x cubed, y to the fourth, all relate in non-linear functions. There are a couple of questions on your homework where they just straight up ask you, is this a linear function? Is it a non-linear function? Or is this a linear function? Yes or no? Like, you'll answer that question. So some of these questions are easy in terms of just describe what it would look like. Again, if you just have an x and a y, that's linear. If you take an exponent or like a radical or an absolute value or some crazy thing, okay, that is what causes it to be non-linear. Now, the good news is for my tests, I will tend to focus, and I'll give you an idea, but it'll almost always be this one, the U-shaped one, which comes off of the x being squared. If there's an x squared in the function, that's what causes it to make that parabola shape. That's called a quadratic. The other one I will tend to use within this unit is the absolute value function. An absolute value function kind of makes a V, okay? I'm not going to have you graph any of these. In my math lab, they may have you match up a function, okay? There's also a really nifty graphing utility. I showed you Desmos before. You're going to want to remember that. Desmos. So again, DESMOS.com is a free graphing utility. You can type in whatever the heck you want into there and it will graph it for you. That gives you a good frame of reference to look at whenever it comes to graphing stuff. Now, you can't use it on your test or anything like that, but for homework, if I had to do 12 problems and they're all pretty similar and I want to double check and I want to make sure I don't make any mistakes, I'm going to refer to Desmos. I'm going to let Desmos graph it, and then I can double check and make sure I'm doing things the way that I want. That way I'm not throwing away time, missing problems that I don't need to miss. So remember, Desmos, free graphing utility. You can type pretty much anything in and it will straight up graph it. I can show you some examples here in a little bit. Anyway, when it comes back to those functions, they're going to have you do a couple of things. Thing number one, they can give you a coordinate to test and they will ask you, hey, is this a valid solution? The way you test a coordinate, or the way you see if it is a valid solution or not, is you simply plug it into the original function. So again, make sure you're paying attention to which variable is which. They're not always in the right order. But in this case, X is here, Y is here. Remember, this is an ordered pair. X always goes first, Y always goes second. So make sure you plug the X coordinate into the X of your equation. Likewise, make sure you're plugging Y, the Y coordinate, into the Y value of your equation. And then I want to see, does this equal? Okay, 3 times 4 is 12, 4 times 0 is 0, and 12 minus 0 is 12. Yes, this checks out. This is a valid, good solution. Is 2 a valid solution? Same game. Plug your X in for X. Plug your Y in for Y. And again, see if that works. 3 times 2 is 6. 4 times 2 is 8. Is 6 minus 8 12? No, not. 6 minus 8 is -2, which does not equal 12. This is a bad solution. This would not be on the graph. So one of the first things they're going to ask you to do, one of the things you should be able to do, is verify, does a solution work? Again, the big thing is with this, make sure you're doing it in the correct order. Again, if they said 1/2 Y equals 4X, is this a valid solution? Double check, make sure I'm plugging my X into the X coordinate. Make sure I'm plugging my Y in for Y. And then again, I want to see, do those balance out? 1/2 times 0 is 0. 4 times 4 is 16. Those obviously do not equal. This is not a valid solution. Is 1/2 and 4 a valid solution? Okay. X is 1/2. Y is 4. 1/2 of 4 is 2. 1/2 of 4 is 2. 2 equals 2. That one does check out. That is a valid solution. And there are lots of different valid solutions. It's not always one works and one doesn't. I could have grabbed any number of pairs of points. I could have 5 that work. I could have 5 that don't work. It all just depends, and you got to check. So one thing they will ask you to do is to verify a solution. Again, just double check, make sure you're plugging X in for X, make sure you're plugging Y in for Y. Follow your order of operations and see if your solutions match up. Now, sometimes they will just ask you to generate solutions. For example, they might just say, graph the function y minus 3x equals 3. I'm going to talk about graphing this with another thing that they may ask you to find. If they told you to graph this function, a great way to do it is to find what are called your intercepts. Your x-intercept is where your graph crosses the x-axis. So remember, on your graph, your x-axis is your horizontal axis. If I want to find the x-intercept, I simply make my y value 0. So I'm going to go up to this graph. I'm going to make my y a 0, and then I'm going to solve for x. So if I take this original function and I plug 0 in for y, and now I solve this for x. So 0 minus 3x is negative 3x. If I want to solve for x, the opposite of multiplying is to divide. Then I get x is negative 1. Now, this is extremely important. Last chapter, when we talked about solving, it was just important to figure out what your solution was, what that x equals. Remember, when you have a two-variable equation, your solution is not just negative 1, okay? That's specifically your x-intercept, which matches the coordinate, okay? X, negative 1, y, 0. So when you give your intercept, make sure you write it as a coordinate, okay? Parentheses, x value, 0, parentheses. Okay, all x-intercepts will have a y value of 0. But that, like I said, specific point is going to be back here. So with a x value of negative 1, y value of 0, this is my x-intercept. Okay, that pairs up with your y-intercept, which again, if your x-intercept crosses the x-axis, your y-intercept crosses the y-axis. Y is the vertical. Same thing, if I want to find my x-intercept, I make my y 0. If I want to find the y-intercept, I make x 0. So now, same equation, I'm just going to plug 0 in for x. I'll do it over here where I got a little bit of room. So y minus 3x equals 3. 3 times 0, 0. My minus 0 is just y. So then my y is 3, which again happens when x is 0. So that matches this coordinate. So again, your x-intercept is a coordinate. Your y-intercept is a coordinate. We graph that one. 0, 3. So that's my y-intercept. And if I want to graph those, I can just connect those dots, and that's where my line would go. So that's a couple of things they may do. When they give you an equation, they may just ask, hey, what's your x-intercept? Or, hey, what's your y-intercept? Or they may ask you both and then ask you to graph it. You can just plot those 2 points, connect the dots. That is a great way to graph. Now, it is possible for your intercepts to be on decimals. When you go to graph, you just got to zoom in and make sure you do that. I think there's actually even a place where you can type in the specific X you want to type in. Most of the time, you're going to get pretty little whole number answers just because it's easier to graph. Okay, and in this class, it's about being accurate. So most of the time, you're going to get pretty little whole number answers. Not always. So don't just think if you got a fraction or a decimal, then it doesn't work. Okay. But most of the time you will get pretty little whole number answers. The big thing, remember, your x-intercept is a coordinate. Make sure you write it like this. The y is always 0. The y-intercept is a coordinate. Make sure you always write it like this, okay? X is always 0. And they're going to give you a number of different possible problems to graph. So if we did another one, let's say, y equals 1/4 x minus 1. Now, there's another way to graph this that I'm going to talk about here in a little bit, but I'm going to keep doing the x-intercept, y-intercept thing. So given this graph, if I want to find the x-intercept, okay, remember I'm going to make y 0. So if I make my y 0, then I'm solving this equation. So I'm going to get my 1 over here on the other side. Now, to get rid of the 1/4, you got a couple options. You can multiply to get rid of the division, or most people just will divide, which is fine. Just make sure you're trusting your calculator to do that, because 1 divided by 1/4 is 4. Some people will try taking 1/4 of 1 and they'll get 0.25 or something like that. 1 divided by 1/4 is just a positive 4. So remember that 4 goes with when my y is 0. So again, that would be this coordinate. Okay, same game. If I want to find my y-intercept, I make my x 0. So y equals 1/4 of 0 minus 1. 1/4 of 0 is just 0. And 0 minus 1 is just -1. So again, that y is -1 goes with my x of 0. So that coordinate is the point 0, -1, which would be that one right there. Again, if I want to draw that line, I would just connect the dots. All right. They do give you a couple of problems that are nonlinear that they want you to graph. So it's again important to note, if they give you one to graph that is non-linear, it'll typically be a squared or an absolute value. Remember, the squared, the general shape is going to be some kind of parabola shape. So that's kind of what we're looking for. Kind of the best thing to do here is just what we call guess and check. So we're just going to plug some numbers in. And for my math lab, you need 3, and really any 3 will work. So I'm going to just pick 0, 1, and 2. And I'm just going to plug those numbers in to my x and then see what happens to y, right? So if this is my function, y equals 2x squared, if I plug that 0 in, okay, order of operations, do my exponents first. So 0 squared is 0, and 2 times 0 is 0. So when x is 0, so was my y. Okay, if I try this one, if I try the 1, so y equals 2 times 1 squared. Again, do the exponents first. So first we do 1 to the second power. 1 squared is 1, because again, squaring something means timesing it by itself. 0 times 0 is 0. 1 times 1 is 1. And then 2 times 1 is 2. So if x is 1, y is 2. Last but not least, I'm going to do the 2. So y equals 2 times 2 squared. 2 squared is 4. And then 2 times 4 is 8. So those 3 points define where my graph is. Now, the good news is you can just draw those or plot those points in my math lab and it will graph it for you. I'll show you how that works, but you'll plug those points in so we can graph 0, 0, graph 1, 2, we can graph 2, 8, which 8 is going to be like way up here, and it will connect the dots and draw the parabola where it needs to be. From 3 points, it knows where it's going to break and curve. So even if you would have graphed one of these points over here, it knows how to do all of that. In fact, I kind of want to show, so I'll leave that here. I'm going to see if I can share my screen and show you what it looks like when you graph a polynomial. Hold on, let me get this over here. Sorry, that's Desmos. Nope. Keep trying. All right. Let's do this way. All right. Pardon me. Once I get this pulled up, I'm going to share my screen again. So if you're not seeing what I'm doing, I apologize, but I'll get that fixed in just a second. There we go. Okay. Bring this over here. Pull that up. Should be able to share that screen. All right, so I want to share that one. This is frustrating. There. Okay. Hopefully you guys can see my screen. It should say like question 13, 3.1.39. So this is again from the study plan. So this question specifically says, looking at the function, and again, you can zoom in on your screen. So if your screen is tiny like mine is and you have bad eyes like me, you should be able to zoom this in. But anyway, the first question is this a linear function or not? Again, with that x being squared, that is not linear. Check my answer. Yay, I got it. And then it wants me to graph it. All right, so I'm going to zoom in. When you do that, or when you click on your graph, that gives you this list of tools. On the bottom, this is important. If you click on the wrong one, it's never going to graph it right. So again, the x squared function graphs like this u. For the straight line ones, you're going to grab a straight line. For the x squared functions, you want to grab this u looking graph. Then you're going to plot 3 points. So just for instance, if I want to use that last problem, which is not going to be right because this is a different problem, but if I wanted to graph 0, 0 and 1, 2 and 2, 8, okay, I just click on those 3 points and it draws the graph for me. Okay, make sure you're on a solid line. If you're on a dotted line, it will graph it dotted in decimal, or MyMathLab will count it wrong. So solid and dotted are these right here. You want to make sure you're using a solid line. And for the parabola, again, you always need 3 points. So even if you only found 2, it's going to make you plot a third one before it draws your graph. So for a parabola, you need all 3 points. Now, any 3 points would work. So if I picked 3 different ones, so clear, yes. Okay, same thing. So if I grab the parabola button, I can click any 3 points and it'll draw the appropriate graph. But you need 3 in this particular case. So I'm going to make sure I'm grabbing the right one. I think you can grab these and drag them too. Yeah. So if I want to be at 0 and +7 and 1 + 7. There we go. So you can grab and drag, and then whenever you want to check, I got the right answer. Yay. That's because I'm good at math. So anyway, that's kind of the mechanics. So whenever it comes to graphing, okay, when you click on the graph, that's where you find those buttons at the bottom where it will allow you to graph that function. So this one would be linear. And then for graphing a linear function, again, I'm going to try and zoom in. You want to make sure and grab the straight line function. And for the straight line ones, you only need 2 points, and any 2 points will work. If you don't like where those are, you can grab them and drag them to wherever. Whenever it's done, again, make sure you're solid line here, and then you'll check your answer. If again you're wrong, you've probably done that before, and it says, "Hey, are you sure?" And you get like one chance to check it, and then if you check it, it'll say like, "Nope," and then try again. Type of deal. In this case, it would be 0, 0 and 1, -5. Yay. So anyway, that's kind of the mechanics for graphing. The good news is you're not completely arbitrarily on your own, but you do need to know the basic shape of the graph. If it's linear, make sure you grab the straight line button. If it's a quadratic, you see x squared, you need to grab that parabola button. Now, there are a couple of others where it may have you match. I don't know if I can find one really quick. Actually, I think they may do this too. This is nonlinear. So they want me to graph it, but then it gives me a multiple choice to choose from, which you can zoom in and check and see which one it would be. So anyway, that's kind of the mechanics of how graphing on MyMathLab works. If you run into something or you have questions, you can just let me know. So that being said, that's primarily what they're going to be asking you 3-1. In 3-2, they transition, and it's really just some naming stuff. So the equation y equals 3x plus 2. This is a linear equation. Sometimes they will change the way they write this. The y is completely interchangeable with this, f parentheses x. This is called function notation. And it just simply writes the equation as an expression of x. These two things mean the same thing. So if you can find the solutions to this, it's the same. Okay, that f of x is referring to the y. So in very much the same way, if I plug 1 in for x, 3 times 1 is 3, 3 plus 2 is 5. So 1 and 5 is a valid solution for that equation. Okay, where my x value is 1 and my y value is 5. Functions behave exactly the same way. If I input a 1, I output a 5. So if my x is 1, then my f of x, in this case, my f of 1 is 5. So again, this f of x relates to the y. So just another name for this, this is your input and your output. Another word they like to use for the x's is the domain. So your domain is the list of all the possible x's. And then the range, I'm going to run out of room. Let's go back here. Range, okay, is all of the possible y's. So that's just some vocabulary, terminology stuff. So y equals 3x plus 2. Function notation, this f of x means the same thing. So f of x and y are basically interchangeable. And again, just some other things they call the x. You can call it the input or the domain. The output, the y's, are also called the range. So they're going to ask you for the domain and the range of some relations, and they'll give it in a couple of different ways. They may list some coordinates. For example, if they gave us a list of coordinates like 1 and 2, 5 and -3, and 7 and 4. So just some random coordinates. Okay, so if they're talking about the domain, that is your set of x's. So the domain is 1 and 5 and 7. The domain is asking for all of your x values. In this case, we've got 3. We got 1 and 5 and 7. If they ask you for the range, they are asking for your possible y values. So in this case, your range would be 2 and -3 and 4. And the order doesn't matter. As a math person, I would prefer to see it go small to big, but obviously I threw a negative just here in the middle just because that's the order they were in. Order doesn't really matter here. You just need to make sure you hit all of them. Okay, so again, your domain is your list of all of your possible.
Watch your head. Whoa.
Sorry. Okay, and then your range is all of your possible y's. And if they list them in coordinate form, really, you can just list that. Now, another thing they may ask you is this relation specifically a function? That's going to be a yes or no question. And that is based off of the domains. If these domains are all different, then yes, it is a function. The range doesn't matter. The range could all be the same, or you could have a couple that repeat, or they could all be different, doesn't matter. Whether or not it is a function, yes or no, is based off of the domains. If the domains are all different numbers, then yes, it is a function. So if we gave a different set of numbers, let's say I want to find the domain of 3, 5, 5, 4, 6, 7, and 3, -2. Okay, again, domain, your x's, that would be 3, 5, 6, 3. Now, if you see the 3 twice, there's no need to write it twice. You can, but it's not necessary. So I would not write any repeats. So my domain is 3 and 5 and 6. I've already got 3 written down. My range is all of my y's, which is 5 and 4, 7, and -2. And again, whether or not this is a function is based off of your domains. And if you have domains that repeat, this 3 goes with 5, this 3 also goes with -2, then this is not a function. All right, another very common way for them to give you a relation, so they could list just a bunch of coordinates. In math classes, I've never really seen this anywhere else. They like to do these little domes, and they'll have some sort of input, and then they'll have some outputs over here, and then they'll draw arrows. Okay. What this implies is this is my input, this is my output. So if I plug 1 in, I get 4. If I plug 2 in, I get 7. If I plug 3 in, I get 5. If I plug 3 in, I get 6. Okay, so again, in this case, my domain would be these numbers, 1, 2, and 3. The range, my output based off of the arrows, okay, would be 4, 5, 6, and 7. And again, this one would not be a function because the 3 repeats. The 3 goes to the 5 and the 3 goes to the 6. If they each had just one arrow coming off of them, then yes, this would be a function because this 3 has 2. 3 goes to the 5 and the 3 goes to the 6, then this is not a function. Now, the last way they could give you a relation, and probably the trickiest way to do this, is they could draw a graph. When they draw the graph, okay, the domain, again, is your x values. All right, the question is being asked, which x values have something on the graph? So which x value will give you something? So if I'm looking at this, so an x of 0 gets graphed, an x of 1 gets graphed, an x of 2, an x of 3, x of 4, x of -1. So all of these x's, okay, get graphed on the graph somewhere. And again, those arrows show that it goes on forever. So again, the way we would say this, your domain, you kind of read it from left to right, and we do that interval notation. So we hit everything forever small, which is -infinity. We hit everything in between, forever big. That would be to positive infinity. So in this particular graph, I'm going to do 3 or 4 examples of these graphs so you kind of get an idea of what they're going to look like. But again, the domain you read from left to right. The up and down part doesn't matter. We read it from left to right. We go forever small, we go forever big, we hit everything in between. That's that notation. Range, that is your y's, that is your up and down. Okay, we read that from bottom to top. So again, how far down does this graph go? The arrows show that that goes forever down. This arrow shows we go forever up. We hit everything in between. So again, my range is all real numbers. Now, the easy question to answer is this a function? There is this nifty thing called the vertical line test. If I can draw a vertical line anywhere on my graph and it only hits once or not at all, then it is a function. If I can draw a vertical line that hits more than once, then it is not a function. This one, it doesn't matter where I draw my vertical line, it will only hit one time. So this is a function. Okay. Don't make fun of my terrible handwriting. I just wanted to use some different numbers here. So this goes to -2 here, -2 down here, to +4 here, the +3 here. Okay, it's not a circle. It's not meant to be a circle. It's this kind of funky looking egg shape. All right. Same. Domain, range, is this a function? Domain, we read from left to right. What is my smallest possible left value? We never go left of -2. Now, if it's an open dot or infinity, we use parentheses. Otherwise, if it's a solid dot or a solid line, we use a bracket. So this is saying that -2 is my smallest possible x value. I don't graph anything over here. There's no graph left of -2. -2 is like where the boundary is. Then left to right, okay, +4 is where my boundary is. I never go right of 4. So my domain is from -2 on the x to +4 on the x. Range, again, we read from bottom to top. We don't go below -2 and we don't go above 3. That kind of sets your limitations. Your graph is going to fall in between this box. This kind of sets the dimensions of the box. And same thing, if I draw a line, it hit more than once. So this is not a function. Okay. If we have something that looks like this, again, domain, we read from left to right, we go forever left, we go forever right, we hit everything in between. That is from -infinity to infinity. It doesn't matter that we go up or forever left here and here. It's just we hit every x value to the left, we hit every x value to the right, we hit every conceivable x value. Range is a little bit tricky. Okay, range, again, we read from bottom to top. We do go forever down, but we only go up to here. So we go from -infinity to -3, and then there's a gap. Okay, if this was connected, we could do from -infinity to +infinity. But with this gap, we have to account for that gap. And again, that's kind of where we use that symbol there. And then we go from +2 to +infinity. And this order matters. Like it has to read from your smallest possible value to your biggest possible value. It has to be written exactly like that. And again, if we draw a vertical line, we're going to hit more than once, so this would not be a function. So you can kind of go through and look at those. Those examples kind of cover a bunch of different topics for nonlinear functions or relations. Okay, then determine whether or not it's a function. But that's one of the things they're going to ask you to do. That's why this section has a ton of problems, because they give you a bunch of different functions and ask for domain and range. And then sometimes they just want to know, is this a function? Yes or no. Okay. Also, they do have you evaluate some functions. So a couple of things that you need to pay attention to here. So I'm going to do these in different colors. But if they said like f of x equals 3x plus 1, and then g of x equals 2x cubed minus x, and h of x equals 1/2 square root x. Okay, they can give you multiple functions. Typically, we use f of x. Okay, however, these play the same. This just gives you a label so you know which function you're dealing with. For example, if they said, what is the f of 5? Again, input, output. They're telling you to put 5 into the f function. So if f of x is 3x plus 1, we're going to plug 5 into that 3x plus 1. So if we do the math, 3 times 5 is 15. 15 plus 1 is 16. Now, what this means, okay, again, input was 5, output was 16. That means that coordinate. So if my x was 5, then my output y was 16. So those functions directly relate to the coordinate for it. Okay, so the f of 5 is 16. Sometimes they want you to write it as a coordinate. They will show you or ask, okay, evaluate the function, and then like, what would that be as a coordinate? Same, they could ask you, what is the g of -3? Important that when you plug numbers in, I would use parentheses. Okay, that's important because when you start taking them to exponents, those parentheses matter. So again, what this is saying is 2 times -3 to the third minus -3. And again, we got to follow order of operations. -3 to the third power means -3 times itself 3 times. So -3 times 3, -3 is 9, times -3 is 27. The negative of a negative is a positive. Multiply 2 times -27 is -54. 54 plus 3 is -51. And again, that output goes with that input. So the input of -3 gives me an output of -51 for the g function. There are a handful of times where they want you to evaluate various functions for various inputs. You just plug that number in, get your output. If they ask you, what does that mean in terms of input and output, that's the coordinate. Now, the trickiest thing they can ask you here, the one that is like, I don't know, kind of atypical, is they may graph a function. They're going to say something like, hey, f of x looks like this. If that's the case, and they say, all right, what is the f of 1? This is asking kind of the same thing. So if 1 is my x, what is my output? So if I look at 1 on the x axis, that is a 0 on the y. So again, at the x coordinate of 1, remember that's the coordinate 1, 0. So that means my output would be 0. Okay, same thing. If they said, hey, what is the f of -2? What they're asking is, if my x value is -2, that's this one. Okay, what is my y value? So at an x of -2, looks like we have a y value of +1. So that would be my output. So again, inputs and outputs work just like your coordinates. So if they draw a graph, it's going to be based off of the coordinate. This is your x. Okay, they're asking you what is the y. If this is my x, they're asking me what is my y. So if my x is 1, my y is 0. If my x is -2, my y is 1. If my x is 0, if I get an x of 0, in this case, I had a y of -1. So it's the same, input, output. All right, last but not least, for 3-3, they're just going to ask you to graph some specific functions, which you can do using any of the stuff we've already talked about. If they told you to graph y equals 3x plus 2, you can graph finding your x-intercepts. You can graph using decimals. You can graph this in a bunch of different ways. Okay, for 3-3, I'm going to show you a different way to do it. It's called slope-intercept form. This is the way you probably learned or remember how to graph the most. In fact, there's a lot of you that whenever I said y equals mx plus b, you're like, I've seen that before. I remember that one. Okay, you couldn't tell me what anything means, but it's like, hey, I remember y equals mx plus b. What this means is if y is by itself, okay, then this number m times x is my slope. And then this number here all by itself is my y-intercept. Y-intercept we already talked about. That's where you cross the y-axis. Slope we have not yet talked about. Slope is rise over run. How much does it go up compared to how much it goes over? Up and over. So if I write this, okay, like a fraction, 3, I can write it as 3/1 if I want to graph this function. Okay, +2 is where I cross the y. So at a y of 2, and then I'm going to have a slope of 3, which means I'm going to rise 3, and I'm going to run 1. So rise 3, run, that means run to the right, 1. Rise 3, run 1. And there's my line. So as long as you can count and you know left from right and up from down, okay, that's how you can graph using slope-intercept form. Okay. Similarly, if they gave us y equals 4/5 x minus 3. Okay, again, as long as y is by itself, we're in what we call slope-intercept form. It's really important. Y has to be by itself. If it's not, we got to get it there, and I'll show you that next. But if y is by itself, then this 4/5 is my slope. So again, that's rise, that's run. This -3 here is my y-intercept. So at -3, it's where I cross the y. And my slope says I'm going to rise 4. I'm going to run to the right 5. So up 1, 2, 3, 4. Right 1, 2, 3, 4, 5. And all I need is those 2 points, and I can connect those dots. Now, if y is not by itself, we can get it there. So 3x minus 2y equals 5. Again, extremely important. Y has to be by itself. If it's not, we can get it there. So if I subtract 3x from both sides, I get -2y equals -3x plus 5. I can't combine those because one has an x and one doesn't. So those two don't come together to be like -8x or something silly. Okay, the 5 is a number with no x, the -3x has an x, can't combine them. Okay, I still want to get y by itself to get rid of multiplying. We divide. When we do that, we got to divide everything. So y equals 3/2 x plus 5/2. Now that 5/2 I'm actually going to write as a decimal to make it easier to graph. So y equals 3/2 x plus 5 divided by 2 is 2.5 or 2.5. So again, if I wanted to graph my y-intercept, it's going to be halfway between 2 and 3, 1, 2 and a half. And then from there, I'm going to rise 3, run 2, and connect my dots. Now, for some reason, every example I picked had a positive slope. So you go positive up and then positive to the right. If you have something with a negative slope, okay, if there's no y-intercept, your y-intercept is 0. And in this case, my slope is -3/1. Though to rise a negative means to go down, and then you still run positively to the right. Or if you want to go up 3, then you run to the left 1. So a positive slope should go up and to the right. A negative slope should go down to the right.
On the last question, shouldn't the 2.5 be negative because the 2 was a negative?
You are correct. So I was working really quickly, but you're 100% right. So 5 divided by -2, that should have been a -2.5. I was totally doing that on purpose to try and catch you. So yeah, I should have come down -2.5 and then graphed from there. So up 3 over 2. You're right. Good catch. Now, there are 2 other things that they're going to try and get you on here. So 2 equations that play just a little bit different. If they give you just a y equation, this is like saying y equals 0x plus 5. And the way that works, we have a y-intercept of 5. And then a slope of 0 is a horizontal line, okay? So again, when you have a y of 5, that says no matter what, your y is always going to be 5, which makes sense because if I graph this point, that would be the point 1, 5. I graph this point, that would be the point 5, 5. Or if I graph something back here, like this would be the point -3, 5. So if my y is constantly 5, that's going to give me a horizontal line at whatever that y value is. And then the exact opposite of that. So if I said x equals, there's no way to put that into slope intercept form because this has no slope. What you get is a vertical line at whatever the heck your x equals. So this would be like the point -3, 3, or -3, 0, or down here at -3, -5. Okay, so if you have just an x equals equation, okay, that graphs with a vertical line. If you have just a y equals equation, that graphs with just a horizontal line. Any other equation is going to yield some sort of diagonal line going in some kind of direction. So again, a slope of 0 is a horizontal line. That's a y equals equation. A vertical line has a slope that is undefined. There's an x equals equation. Anything else will yield either a positive slope or a negative slope. And anyway, 3, 3 just gives you a bunch of different equations that they want you to graph. And again, a great tool for graphing is Desmos. I'm going to try and share my screen again. Hopefully all these screen shares work, but if you go to Desmos, which hopefully everybody can see, okay, it's just a free graphing utility, desmos.com, and I can literally type in anything I want. Gotta get my keyboard here. X, Y. Oops, can't even see in there. And it'll graph that line for you. And then I can find specific coordinates, highlight those. So y equals 3x minus 5. So here at -5, then you can highlight and see that's the coordinate 0, -5. Okay, that coordinate is about, yeah, there we go. I had it 1, -2. So you can click on here and you can find specific coordinates like 2, 1. And Desmos will graph anything. So if I wanted to square that, you've got an on-screen keyboard, square those, and then it'll graph those parabolas. If I wanted to cube it instead, you can see that's where you get a graph that looks kind of like that number there. Anyway, Desmos is a great tool to use just for comparing your graphs. So it is just a little bit early. I got 8:06, but that's 3 sections. Now I didn't break it down quite like I did with my others. That's just the nature of, yeah, sorry, if I go back here. I don't need to turn my video off. I was just trying to switch. Okay, so like I said, I didn't break it down because these sections all kind of overlap a little bit. 3.2 is the only one that's kind of standalone because that's the function stuff, the domain and range primarily, but it still overlaps. But 3.1 and 3.3 are very, very, very similar in what they ask you to do. And you can use any of those tools, just need to be able to graph. So I'm going to stop the recording. I'm going to upload this to Canvas, but if you have any questions, feel free to stick around and ask them.